This is the real deal. I think it's going.
Yeah, we're live now.
So, does someone want to walk me through this first one? Because I've read through all the PowerPoint, I've read through all the notes, and I still seem to be getting different. Like, when I went back to the study guide, like the one that was due on Wednesday,
Yeah.
looked at my answers compared to the key. They were both a little bit different, like not much different. Like,
Did you watch her video?
I did not watch the video.
Yeah, the video was really helpful for me on that one.
Because I spent like an hour and a half trying to figure it out. And I got part A. That's what I got right. And then the rest of it, yeah, I gave up and had to watch the video. It was hard, man.
Yeah. Yeah. But once you watch the video, it makes perfect sense.
Like, I even noted, like, I got this without giving up and watching the video. That was the only part I got right, and then the rest I had to redo.
Alright. So I'll probably have to change my answers.
Yes. Because we have to do this again for the one that's due today. So, as long as, I don't know.
Yeah, like, the one that's due today, everything's pretty much the same. It's like the same problem over and over again, 9 times.
Okay, so do you want to walk through it? Actually, hang on, Steven, can you walk us through what you did, so we can see like the stuff that you did, and then we can help you out?
Yeah. Give me a second before you pull it up. Are we walking through the one that was due on Wednesday, right?
Yeah, yeah.
All right. Let me find it. All right, so I got the allele arrangement of the dominant parent for number 1 as colorless, waxy. Wait, no, hold on, just a sec. Yeah, colorless, waxy, and dominant, which I believe was plump, right? Anyway,
And plump.
Colorless, waxy, plump, and over colored, non-waxy, shrunken. For the gene order, I found it to be waxy, shrunken, colorless, or however you want to phrase that. Waxy, colored, waxy, shrunken, colored. But with the waxy gene coming first, and the shrunken, and then the colored gene. For the linkage of colored to waxy, I took the 2 most dominant, the waxy plump and colorless, and the non-waxy shrunken and colored, and I also did it with the, let's see, non-waxy plump and colored, and the non-waxy shrunken, wait no, non-waxy shrunken colored, and the waxy shrunken colorless. So the double crossovers offspring. So I did that. So it'd be 35 over the total offspring for those 4, right?
So almost. The 35, yeah. But then you've got to pick out which ones are the normal crossovers. So the 15 and the 20, those are the double crossovers.
Yeah.
But then there are 2 single crossovers, and you have to add all those together over the total number of offspring. So in this case, the single. Trying to figure this out because I didn't write the the phenotypes.
So the waxy, plump, and colored as well over the.
Let's see, it's colored, waxy, plump, and colorless, non-waxy, shrunken. And then the colored, non-waxy, plump, and the colorless, waxy, shrunken. You add all of those together, and then it's going to be over the total offspring.
So the 84, 20, 99, 15 over the total offspring.
Yeah.
Yeah.
And then multiply that by 100, and then you get 3.2.
And that's the distance between the C and the SH.
But that still doesn't. Oh.
Does that make sense?
Yeah.
And then you do the same for the waxy to the shrunken. You just find the double crossovers and the single crossovers, and then add them all up over the total number.
Waxy that is shrunken. That gave me the waxy that is shrunken, though.
What was that?
Yeah, I can't hear you.
The equation you just told me gave me the waxy that is shrunken, so how do I find the color of the waxy?
The colored, waxy, plump?
No, the distance from color to the waxy gene. Because you just gave me the waxy to the shrunken gene.
Yeah, and then you do it for the colored to the shrunken gene.
I don't follow.
No, the one we just did was colored to waxy. The 3.2 is colored to waxy.
Alright.
Oh, yeah.
Yeah.
And then which ones do I use for the waxy to the shrunken one?
That would be, let me see here. Let me get up the phenotypes. So it's going to be the double crossovers, so it's the 15 and the 20. And then it's the colorless, non-waxy plump, and the colored waxy shrunken. Because instead of swapping the C to, or the colored to waxy, swap the waxy to shrunken.
So it's the colorless,
that's what you get.
Waxy plump.
Color is colorless, non-waxy plump.
Colorless, non-waxy plump.
Yeah, and then colored, waxy, shrunken. The video that she posted explains it a lot better than I could do it.
Yeah.
The way that you determine that one. Oh, I don't think I can post it in here.
Alright, so colorless, waxy plump. Is that what you said?
Hang on.
Sorry.
Colorless, non-waxy plump.
And which other one?
And colored, waxy, shrunken. So it's the 974 and the 951.
Over the total amount of offspring?
Yeah.
And then those are the single, what's it called?
Crossovers.
Single replacement? Whatever. And then, and then the double, or the 20 and the 15. So it's the 20 and the 15, and then the 974, and the 9, all over the total amount of offspring.
Alright.
Yeah. And then you just rinse and repeat 5 billion times until you get this all done.
The double crossovers are used in both then?
Yeah.
Alright.
Yeah. So really, you only have to, those are really easy to find because they're always going to be the two lowest. Mm-hmm. And then after that, you just have to figure out which are the other two that belong.
Alright.
And then D, I don't even remember.
Yeah, D, it was easy for me just to see it on the video and then.
This is plug and chat.
It's not too hard though.
Yeah.
Mm-hmm.
And then you just keep doing them. For number 3 though, actually, let me look at the. I didn't even look at the key yet. For number 3D, I got like a ridiculously huge number. That doesn't seem right.
Let me pull mine up quick. Where did it go?
Oh, there's the key. Let me see this. She said it was something because there are only 6 types or something like that instead of 8.
Oh.
Wait, hang on. What does the email say exactly? Alright, so she said there are only 6 phenotypes listed, and the trick is discovering why that is, and what 2 phenotype categories are the most likely to not be represented. I don't know. That's why I got it way wrong. I'm sorry I burped. Yeah, it's going to be recorded. I'm sorry, Sister Mayo.
I'm trying to remember what I did here. Let's see. Wait, you're on for number 3?
Yeah, number 3D. Because number 2 is pretty much like number 1. Check to make sure you got it right.
So, are you looking at the applying genetics problems?
No, the group problem ones. The ones due on Wednesday.
And you said there's only 6 phenotypes listed?
That's what she said in the email. Because she sent out an email to everybody kind of saying that this is a tricky one and all that. I see... Well, there's 1 phenotype, 2 phenotype. I don't know.
Because on the applying genetics problems, there was one that only had 6. And that was really weird.
Oh, wait, no, that's the one she's talking about. Never mind.
Okay.
I take back everything I said. Don't worry about it. Never mind.
Okay. Yeah, I was a little confused for a second.
Okay. Well, that's what I meant. See? Just trying to keep you on your toes.
So yeah, on that one, you have to plug in 0 because there's 2 that aren't there, and so you have to do the double crossovers don't exist. And you just plug in 0s, and then it all works out.
Well, that's good to know.
Mm-hmm. Yeah, that one kind of stumped me for a bit. But. Have you guys done the applying genetics problems yet?
Nope.
Okay.
The one that's due today?
Yeah.
I started it, but
I read it.
Problem 5 yet?
I wasn't really understanding where to go with it.
Okay.
But yeah, Steven, watch the video that she posted, because it's like a step-by-step, really, really, really helpful thing.
Alright.
Yeah, I don't think I could have finished this without that.
I definitely couldn't. I was getting angry. It's hard, man.
Yeah, it's confusing. Well, all those are pretty much the same. There's not much difference between. I'm trying to remember if I had any other hiccups anywhere or not.
Do either of you happen to have a screwdriver? Okay. Worth a shot. Alright, so I suppose that is that.
Sounds good to me. You guys good?
I think so.
Okay. What time works good for everybody next week?
What Thursdays, Fridays usually work. I was out of town Thursday and Friday today, this week, but usually
like Thursday at 8?
Okay. Thursday at 8 sounds good, yeah.
Sounds good.
Perfect. Alright, sounds good. Thanks, guys.
Alrighty. See you next week.
See ya.
We'll see ya.